I've started now. The private connectivity. Oh, you already did.
Oh, okay, time one.
Okay. So the private connectivity between the virtual network is not yet configured. So several business units have identified services in the virtual network that need to communicate with each other. So several business units have identified services in the virtual. So once you deploy different of their services, right, into different virtual networks. So once it creates the problem for you, and you know, provide a solution, right? So one of the solutions is to do what we call network pairing, right? So you are responsible.
Yeah.
It's a costly way. You are responsible for implementing the virtual network pairing solution. And you're also responsible for enabling connectivity between the virtual networks. Okay. So two of your strategy goals include preventing exposure of the services to the internet. So security is very important. These services must not be exposed. Our deployed services must not be exposed to the internet. You know what they mean by to the internet? That is, we don't want
nobody can come in from outside.
From public. You know, for example, you want to put public IP. Because once you put public IP, what happens? People can connect to that service publicly.
Open to the internet.
You understand? Then when you go to your network security group, you know how to set up your rules to make sure that you restrict accesses, from public. And keeping integration very simple. So that's what I'm going to be learning. So. Determine virtual network pairing uses. Okay. Perhaps the simplest and quickest way to connect virtual network is to use Azure virtual network pairing. The simplest and quickest way to connect your virtual network is to pair them. So virtual pairing enables you to seamlessly connect your two Azure virtual networks. So after the networking appear, two virtual network operate a single network for connectivity purposes. So it will now look like the virtual image you have a very large network, like a one, which is your wide area network, something like that. But you see, you look as if they are the same, maybe like a single one. Like two things joining together to become one. They'll be able to talk to each other. Now, things to know about the network pairing. So let's examine some prominent character in your network pairing. Number one, there are two types of network pairing. One is regional, one is global. Can you explain the regional and global to me?
Yeah. The regional is like for example now the one you said Texas, the one in city, the two cities you mentioned, not New York, not New York. The one Dallas and this thing, they are the regional. The global is the one that is exists in another region. Okay, let me just say this way: the regional are the one that are in the same region. The same region. Why the global are the one that are in different region, not that doesn't exist in the same region?
You understand? So as you can see it in this diagram, you can screenshot if you want to, but at least you've been able to get the idea. If you look at this region now, you see that both of them are in the same region. So VNet 2 and VNet 3, we pair them together. That is regional pairing. So we pair VNet 2 and VNet 1 together. That's a global pairing because they're in different regions. So regional pairing connect Azure network that exists in region. Global pairing connect Azure that exists in different region. So you can create a regional pairing of virtual network in the same public cloud, or in China, or in government. Don't worry about that. You can create global pairing of virtual network in anyone. Okay, let's move on. Things to consider when using Azure. So what are the things you need to consider? Private network connection. So these are part of the benefits. So when you implement network pairing, so your network traffic between paired network is private. So every email, more than you create VPN, or it's private. Okay. So traffic between the virtual network is kept on the Microsoft backbone. Don't forget this. So it runs on the Microsoft backbone. That is, Microsoft have laid cable from one data center to another data center. So you're basically browsing via the virtual machine, and you're browsing. You're browsing via a private channel, that is owned by Microsoft. They are backbone internet. So it's not exposed. It's not exposed to the public internet. You understand? Those people, they've been able to master the art of internet too. So no public internet. You have to cost you. No public internet, no public gateway, or encryption is required in the communication between virtual networks. So there's no need for encryption, right? You understand why? Because it's already in Microsoft backbone, so secure. So the communication is like you living in a how will I put it now? Maybe you are in the campus, right? And all of you are in the dormitories in the campus. So none of you lives there. So whatever you guys do in campus stays in campus, right? So that's how it is. So you got all your phones, all the lifestyle, nobody cares what is happening there. That's how it is. There's strong performance. Then because virtual network pairing utilizes Azure infrastructure, so you have what we call low latency. So give it to one low latency. Give it to one latency.
Low latency is because there is no delay.
There is no delay, right? Good. So you have very low delay, So the speed is very high. I don't know if I've shown you the speed in the virtual machine before. Within Microsoft Data Center, the internet speed is about 1 point something gig Gbps per second. Very mad. So there's a high bandwidth connection, and they don't charge for all those things. They don't. Simplify communication, seamless data transfer, no resource disruption. Okay. So let's just move on. So determine gateway transit and connectivity. So when virtual network appeared, you can configure a VPN gateway in the paired virtual network as a transit point. Okay, in this scenario, a paired virtual network uses a remote VPN gateway to gain access to other resources. So consider a scenario where 3 virtual networks in the same region now. This is the same region now. That's a regional. Are connected by virtual network virtual network A and virtual network B are each paired with a hub virtual network. So now look at this diagram.
Okay.
Look at this diagram. You might want to take a snapshot. Okay.
Okay. Snapshot.
So you understand? So you have, with the course of your training, you've created a lot of virtual networks, you created subnets, and you've done a lot. So there's nothing scary here, So you should be able to explain this diagram to me. Please go ahead and explain this diagram to me. Can you explain this diagram?
They have done it, yes.
Yeah, I wanted you to explain this diagram to me now.
Okay, you want me to explain it?
Yes. It's virtual network. No, it's now.
Okay. So in this diagram now, we have two, no, not two, virtual network. We have 3 virtual networks.
Yes,
A, B,
correct.
C, and hub virtual network.
No,
So
not
in
A,
each
C.
one,
C.
sorry, A, B, and hub virtual network. A, B, and hub virtual network, which is 3. The hub,
So
yeah.
A and hub are also called what?
The hub,
The A and
It's
B
the one that
are also called what? What's the other name? You can also call your A and B.
A and B. The more Urban, only Urban spoke abi.
Yes, exactly.
Huh?
Yes, sir.
All right. Okay. So here we have for each one has one subnet each, and then one subnet each. So there is the communication. Which one is this one? The subnet. This is virtual machine. Okay. Each one of them. Okay. So for A, he has one virtual machine. B has one virtual machine, and then the hub virtual has the hub has three virtual machines.
No.
Three virtual.
The virtual machine.
And now, this is not the virtual machine. Which one is this one after MVA? Is that the virtual machine?
That's your network virtual appliances.
Okay, what's virtual machine?
Well, you can assume you can call it virtual machine, but you should say
and then you have another virtual machine. Network appliances.
Something like something that works like a router. If you remember your router, your switch, something like that. Like a jump box.
Okay.
Not a virtual machine pass. But it's a machine.
Okay.
Go ahead.
Okay, so and then this one has clearly security group clearly to lock by.
Go ahead, sir.
Okay, so there's a connection. Okay, sorry, the one that we don't see is there's a communication between the virtual machine in net A and between this and the not virtual the MVA in B. But this one is this security group or it's locked. The key, the padlock. I think the padlock is locked to any communication. User define routes. UDR. Okay.
Oh, okay. The yellow padlock, I mean.
I don't understand what it is. Okay, it was encrypted. Okay.
What's encryption?
Okay. So from what I see is that there's a pairing between the virtual machine A with virtual machine hub. Virtual network A and virtual network hub, and then virtual network B and virtual network hub, and then and then there is a gateway. There's a VPN gateway that communicated to the on-prem.
Okay.
So, and then from what I see, actually, there's no subnet here. I don't know if there's subnet there. I noticed that there's no subnet in this other yes, I think subnet doesn't have subnet here.
Nibo.
The other two the two virtual machines here, they don't have subnets.
Are you sure?
Okay, I think no, there's no subnet there. They don't have one subnet here.
The diagram will
No, there's only one subnet for the virtual machine and for the MV. The other virtual network, the other virtual machine doesn't have subnets.
There are subnets. But for that people call subnet, it's only one. That's what they mean.
So much more. Okay.
Subnet meta. When you are creating your virtual VPN gateway, it will be separated on its own separate subnet. On its own separate subnet. When you create NVA, no on its own subnet. Our workstations in, our virtual machines in, they will be on another subnet. So subnet meta low and LVnet. Kò yé yín bẹ́ẹ̀ sà.
Okay.
Àti pé tẹ bá wo diagram yẹn náà from network A and network B, they are similar size na subnet yẹn. By now you should know that when you have your VNet, internally they will have subnet. Kò sí VNet tó yẹ bá ní subnet because they only be a default subnet. Understand?
Okay, so
okay. Ẹ bá kọ́lé kan náà the least ẹ lè yọnu ilé yẹn òun yàrá kan true of us.
True.
Mo odidi ilé ni mo yàrá kan lè yọ náà. So the idea is there must be a room, something that looks like a room in any building that you have. Either it is 1 bedroom or 2 bedroom. So anytime you have a virtual network, by default, you don't want any other subnet. As a subnet because subnet whatever you want to take off a deploy, you know, like one. So I'm create another one.
So naturally they have default subnets.
Yes.
So they don't quickly for them, they don't serve with default.
So you use network A and B, yes, default network, default subnet now machine.
Okay. So a cast statement while location. Oh my god, dancing. Okay.
A caster.
Okay. Determine gateway transit and connectivity. When virtual network are paired, you can configure Azure VPN gateway and the paired virtual network as a transit point. In this scenario, pair virtual network used the remote VPN gateway to gain access to other resources. Consider a scenario where three virtual networks in the same region are connected by virtual network pairing. Virtual network A and virtual network B are each paired with a hub virtual network. The hub virtual network contains several resources, including gateway, subnets, and a VPN gateway. The VPN gateway is configured to allow VPN gateway transit. Virtual network B access the resources in the hub, including the gateway subnet using a remote VPN gateway.
What's the name?
Cheering now.
So what are the things to know? So you do this one.
Take a closer look at how Azure VPN gateway is included in Azure virtual network pairing.
It's very important
let's
to look.
Let me click short before I start.
So take a look again.
Take a look at what?
The VPN gateway. Delay.
Okay.
This gateway now gives the opportunity to create what we call VPN gateway transit to this particular network here. And then the same gateway is allowing you to communicate to the on-premises.
Okay. Hey. Stop.
So go ahead.
All right. Take a closer look. Take a closer look at how Azure VPN. Go ahead, Joe. First, take a screenshot.
No problem.
Yeah. Control V. Okay. A virtual network can have only one VPN can only have one VPN. A virtual network can only have one VPN gateway. A gateway is support. A gateway transit is supported for both region and global virtual network pairing. When you allow VPN gateway transit, the virtual network can communicate to resources outside the pairing. In a simple illustration, the gateway subnet gateway within the whole virtual network can compete tasks such as these are such as you use a site-to-site VPN to connect to an on-premise network. Use a VNet to VNet connection.
I understand statements.
Use a site-to-site VPN to connect to that's into diagram in here.
Okay.
VPN to one diagram in.
I understand. Go ahead.
Use a VNet to VNet connection to another virtual network, which is number the hub. Yeah. Use a point-to-site VPN to connect to a client.
But that last one, did you see that in the diagram?
Use a point-to-site VPN to a client. I think. Can you give me the diagram? I'll show you. It's there.
Okay.
Use a point-to-site. Use a point-to-site. Allow VPN gateway to transit. A point-to-site. Use remote VPN. I think it's this one. I think it's this. User-defined UDR route. So a point-to-site. Allow VPN gateway transit. A point-to-site. I think it's this one.
Which one is that?
This one. Don't pray. Hey, that part, I'm sorry. Let me read it again.
Okay.
It's learning, I'm learning. I think that part. Network.
This is the diagram.
Use a point-to-site. No, Use a point to site VPN to connect to a client. A point to site. Use a VPN to VPN. Use a site to site. A point to site VPN to connect to a client. A point to site. Ẹ jẹ́ kí n wò ná. Oya diagram a point to site. Point to site.
Diagram.
Yes. A point to site. The point to site. This is the point to site. Now this one, on-prem in. On-prem is the site, right?
Mm-hmm.
The point to site to connect to the client. The point to site to connect to the client. Actually, this is to on-prem.
What's the cost better now? Hey, what's the first one? Hey, what's the first one now?
Oh, the first one, yeah.
First one is site to site VPN now to an on-prem network. Have you read the cost?
So this one, number one, I get a point to site to clients. I get to symbol here.
We want a point to site. I mean, point to site VPN that now connect to a client.
I get two.
One there.
Client. Point to site to clients. Subnet. Point to site is point to site.
Network A is a site. Network B is a site. Hub virtual network is also a site. On premises is also a site.
So a point to site now.
Okay, so if site to site. So you want to point to a site or a site to a point.
A point to a site.
So, a point
to a site.
VPN gateway. Look at this diagram. VPN gateway. Line me lower no gateway.
Mutiri. Ele a point to site. Ele a point to site. So this point to this site. This point to this site. Really? Okay, you cannot see it. You are sharing. Okay. So a site to site. Site to site.
Okay, share your screen.
I mean, the link content show. Okay, I can screenshot, but I can share my screenshots. Which I want to get me today, so that you know that I am alone to have this.
No, I want to get me. I'm okay once you understand the basic. I'm talking about networking.
But you share screen, so sit down, don't go anywhere. Come here. They might dancing, black man. Well, two in your school. Too much share me.
No, drag them in my lap.
You know. Okay. So a point to site from a point to site. So if this is a site, this is a site. This is a site. This is a site. So a point to a site. No. This is a site. This is a site. This is a point. Then they call it Jade. I mean VPN gateway. VPN gateway to the on-prem, no. Because this is a site to site. This is a site to site. This is a site. This is the only one that goes from off site to point to site. But this is not a site.
Which is not a
This
site.
one, earlier on your site, this VPN gateway is not a site.
It's a site too. Central network, lower now, which is your virtual, which is your hub virtual network.
The virtual network logo is a site now. So to me, site inside site.
Yes, you get. Okay, let me explain to you.
Okay.
Imagine that your hub virtual network is in Dallas.
Okay.
But that's the headquarters. Virtual network A is in Houston, right? Now, virtual network B is in New York. Now, your on-premises is where your data center is. The data center can be anywhere. It can also be in Dallas, right? It can also be anywhere. Never visiting. The only difference, sorry, sir. The only difference there is that it's an on-prem. So, within your central network, which is your hub, you have deployed some resources there that will work centrally for all the networks. It's like a coordinating network. So, within the network now, only one is central. So, every other network is connected to this central. Do you agree?
Yes.
So, if it is a virtual network, BTT, you need to pair them together. That is why you can see that pairing happens between VNet B and the hub. Another pairing happens between VNet A and the hub.
And the hub, yeah.
Ever repairing láti lára A and B. Ẹni pé kò sí pairing lára A and B. Now, Kinitan is like an octopus that has eight hands. So VNet A is one hand, VNet B is another hand. Then on premises, where your physical on premises are, is another hand, right? Which is also a site on its own. But how can a virtual environment, your virtual network, now communicate to your on premises? You now need a device called VPN gateway. So you will deploy a VPN gateway, which is also an appliance in its own subnet. You now connect it, or there's a connection when you connect it to your on-prem gateway. So that becomes your site to site. Are you getting me, sir?
Okay.
Your peering too is the same thing as your site to site because it is private. Like you have read, Kato David diagram. Now, based on your IP configuration, based on your networking configuration, which is using gateway now. Anyway, the particular gateway gives you what we call IPsec. You understand? Which is either it is site to site, that is S2S, or a P
Point to site,
which is point to site. Kini point? If it's a problem here, one later. If the point simply means a device. Simply means a device. So the diagram who is saying, kini ko to jomo device to connect mo VPN ní bíbá.
Device to jomo VPN.
To connect mo VPN ní bíbá.
Eléyìí.
Èwo?
To connect mo VPN. Only virtual network B.
Yes, that machine, VNet, B virtual network, is connected directly. Yeah, relying Look at the line now. It's connected directly to the gateway.
To the gateway.
That is a point to a whole site of virtual network. Your hub network. So that's your point to a site. Are you getting the idea?
I get it now.
So apart from all these VNets talking to themselves, with the power of your gateway, you can also help them to talk beyond VNet again. Let me share my screen. Because point to point fast start my phone. Let me know if you can see my screen.
No. Wait, I think it's me. Yeah, I can see your screen.
Now, look at the statement below. The statement says, take a closer look at your VPN gateway. Is implemented in VNet, right?
Yeah.
So a virtual network can have only one VPN gateway, only one. And Google network here, your other two. Because once you get them together, all of them begin to talk to themselves as one, as one single entity. So you only need the VPN to extend your network again, either to an on-premises. Do you understand? So gateway transit is supported for both regional and global. That's where I'm going. This is where I'm going. The one that says, when you now allow VPN gateway transit now, when you allow it now, which is deploy it, just like the way you are looking at something. So your virtual network can now communicate to resources outside their parent. Hub, a hub more network B, a hub more network A. So gateway help you to now communicate outside those parents, because those parents are now one. That is when you now have opportunity to talk to your on-premises. So he said in our sample illustration, to our looking, your gateway subnet, the gateway subnet gateway within the hub virtual network can complete tasks such as you can do a site-to-site VPN connection to the on-premises. It's really site to site, because on-premises is also a site. The hub is also a site. Then you can also do what we call a VNet to a VNet connection to another virtual network, which is the same line. Because one network here, go to the back client here. And then the same gateway can also do your point to site to a client. A client is just a single, what's it called now? A single machine. So when you are working in a company, sir, and then you get to the office, all of you are working in the office and you log in and all of that. And then they just said, oh, for next week, all of you should go and work from home. You don't know that when you get home, you need to log in from your home house into the office network. You don't know you need to do that. What helps you? There's a client, there's a device, there's a small application that's my physical laptop in VPN client. VPN client. We go and VPN now we connect more VPN client. So VPN clients you only connect more gateway toward the edge of your network. You might create a VPN, a virtual private network, to my phone passageway into the office network. So as at that point, your laptop becomes a point that is connected to a site. I don't know if you understand that.
Okay, man.
Okay. So read the remaining parts.
Gateway transit allows shared virtual network to share the gateway. To share the gateway and get access to the sources. I just 1 minute.
That the room is becoming too stuff. The room is becoming too stuff. I'm not saying this kind of truth. What do you mean stuff? That's what I mean. What do you mean stuff? Like making it speak like. There's nothing I say that isn't supposed to be in the you know how it's doing when that check comes, more time to realize. Today. Congratulations. I should do what? I still don't care what that. No, I don't eat coffee. Are you serious? You don't know about that. I only eat coffee, but I only eat carrots. I only eat something. Awesome. Fast. I usually don't take watermelon. But later, started taking. What food do you take? Well, you're lactating. You're lactating. I think it's the best thing is under. Well, expansion. My head, man. Not so okay anymore. Huh? Not so okay anymore. If I trouble to lactate. Right. So you have to be very okay. No.
Sorry.
Oh, okay, sir. So, should you understand the by itself, or do you have a question? Hello?
Hello, sir.
When you understand what Gbogbo by itself, do you have a question?
Shit.
Hello, can you hear me, sir?
That's all I mean.
Okay, so I was asking that. Do you understand Gbogbo by itself, or do you still have a question? Can you hear me? Hello, can you hear me, sir? Hello, can you hear me, sir?
I can hear you.
Okay. So, Moni, hope you now understand this particular concept. Listen, Abi, you have a question.
To understand them, see. The thing is to recognize the 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 resources cleaning to get to the site to get the application or the point of from a point to a client.
So, I know that's the new concept. That's why I was trying to make sure that you get that. So, creating a virtual network peering. So, in Azure network peering can be configured for virtual network using PowerShell, CLI, or you can also use Portal. So, things to know about creating a virtual network peering. There are a few points to review before we look at how to create the peering in Azure. So, to implement VNet peering, your account must be assigned a network contributor. At least you must be a network contributor or classic network contributor. You don't need that one. You are the owner. You account in front, Abi. So you are a global administrator.
So
So you are just going to have assigned custom role. Alternatively, your Azure account can be assigned a custom role and complete necessary action. Okay. So to create the peering, you need two virtual network. These two virtual network. So the second virtual network in the peering is referred to as the remote network. Okay. Initially, the virtual network in your the virtual machines the virtual network cannot communicate with each other. Initially, the virtual machines in your virtual network cannot communicate with each other. So after the peering it is established, the machine can communicate over the peer network based on the configuration. Okay. So get consumption as well. So so we need two virtual networks. Okay. We need two virtual and they manage the two virtual machines. Okay, each one will be in their subnet. They come out ní Abuja, they come out ní Ibadan. So, but the moment you pair them, those two machines should be able to talk to themselves. That's what they are trying to say. So, how to create a virtual network? Sign into Azure Portal, choose a subscription, create this, click on add, create this, create the name, traffic for the blah 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 blah. So check your pairing. So the reasons we keep a little bit maybe action points. So we do it.
Okay.
So next, extend pairing with. Okay, or perhaps let's do it. Let's do
Okay,
it.
sir.
So sign into your Azure, which I feel you already know. Choose your subscription. Create virtual network to include peer network. Okay, Adrona. I want to be sure that we're seeing all the activities in before you start to check your network. Yeah. Extend pairing with user defined routes for service chain. Things to know. Okay, there's an interactive lab simulation. Cool. Okay, I know what to do. So here he's saying you should create the virtual network pair. So create two and then choose the first network and then select setting, then add pairing, configure it. So it's just giving us how come for any direction, should get. So we'll go back to it, right? You know, there's always a link I've always sent to you. See about actions, remember.
Yeah.
So that let's just finish this topic. Extend peering with user-defined route. This is what you want to learn now. Please, you must understand this user-defined route. So what are user-defined routes? Virtual network peering is non-transitive. So the communication capabilities in a peering are available to only the virtual network and resources within the peering.
Come here.
So they cannot transfer it.
Come here.
So
Stand up.
Okay. So Google communication it stays between the peering. So this is the idea. So imagine if you have two buildings, right? So each building can be individually be on their own, right? So maybe one way or the other, each building okay is around. You know what I'm trying to say? Our buildings okay is around. So one way or the other, at the back door and the other building's back door, you now create a channel. You understand? So that creates a channel of like a wall. You now open this door and open the other door. So what do you expect? Anybody that entered the building can find its way to the other building, right?
Okay.
So that's exactly what your peering is. So it means that once you enter building A, you have the ability or you have the capability to also get to the other end of building B. Because barricade to line once you join there, you understand? So now what they are trying to say now is communication is within the building, right? It stays there. So other mechanisms are to be used to enable traffic to and fro from resources and network outside and user outside the private peering network. So there's a concept where we call traffic. So anybody to want move from the first room to the next room, that is a form of a traffic. Then to want move from the second room to kitchen, that's a form of the traffic. But if the kitchen one in the backyard, and then the kitchen's backyard has been joined to the other building's backyard, right? So to move, so one have to enter second building. So the kitchen in kitchen second one, then from the kitchen of the second one, only boss down. From the other room, only boss sitting room. Do you understand that movement, man? So imagine that as routing. Routing means that the way your traffic is moving from one point within your network to another point. Okay.
Okay.
Suppose you have 3 virtual networks, which is your A, B, and C, right?
Yeah.
So you establish a virtual network pairing between you, and then also between B and C. So shall we go on with based on this pairing? Based on this pairing, we might help us. So this will be B. B might help between C and A. There's no pairing and B and B and B might help to my central.
Yes, B might between A and B and C. So we can between
so you don't set up pairing
B and also B, C. Okay. B center.
You don't set up pairing between A and C. So the idea is to just join the network together. Pairing capabilities that you set up between network B and C don't automatically enable pairing or communication capabilities between network A and C. Nǹkan tó ń tọ́ láti sọ sí ni pé nígbà tẹ set up pairing between A and B does not mean that automatically B and C will be paired. You have to go and set it up by yourself, right?
Okay.
So things you know about extending pairing.
That's for me.
Yeah.
Right?
Yeah.
Thank you.
So there are a few ways to extend the probability of your peering for resources and virtual network after your peering network. Of course, you learn about your hub and spoke. So you are learning about your user-defined routes now for service flow. So you can implement this mechanism and create a multi-level hub and spoke architecture. These options can help overcome the limit on the number of virtual network peering per virtual network. So the following diagram shows a hub and spoke virtual network with a heavy gateway. So the hub and spoke network is accessible to other virtual network via user-defined routes using JUL. So if you look at this diagram now, user-defined route. So from network, this is hub virtual network, no alignment. Then you have network
Yes.
6 and network 3. You have network D and network D. So your user-defined route is network low between this machine and your gateway. And the same thing between this machine and your MV. Okay.
Okay.
And then the same. I will look at the direction of the arrows. That's how you know how the traffic is going. Okay. Then basically traffic is coming to the central hub. They remove your data.
Yeah.
So you can't see the traffic leaving this other machine to come and jump on that. So your hub and spoke, when deployed, the hub and spoke network, the hub virtual network can host infrastructure components like your network virtual appliances and Azure VPN. So all the spoke virtual network can then pair with the hub virtual network. Traffic can flow through NVA and VPN gateway, right? Just like we are seeing here. The traffic has to pass through these appliances.
Okay.
You can screenshot that if you want to. So user-defined route.
This mechanism or the diagram?
Yeah, the diagram. The diagram. You understand, man?
Yes.
Okay, good. So your user-defined route. Your
I mean, this
network.
diagram here, John.
Okay, sorry.
Okay, you can take it.
Okay.
Patrick, what
So
is
your
wrong?
user.
What did you eat? Why? Get the fuck out of here, bro. What the fuck is that? Why you messing with me? Ah, boy, it's going to be too much. You can't. Sorry, book on it. Why? God damn it. Patrick, you need to stop passing this stupid gas, okay?
Okay, good. So your user-defined routes now. So your virtual networking peer enable the next up in a user-defined route to be the IP address of the virtual machine in the peer virtual machine or VPN gateway. So ìdílé when traffic jump from here now, from this one now, ilé tí ẹ kó lọ, ó máa wá jump sí your appliances within this here. Kó tó di pé ó jump lọ wá. You understand? Tí traffic bá tún fẹ́ padà wá báyìí, ó tún máa padà wá báyìí wá sáàrin gateway, àṣẹ ti padà wá bẹ́ẹ̀. You understand that? That's what the mean for user-defined route. Okay, interactive lab simulation. So this is what you're going to do.
What's the plan?
No, you will get it now. When you study the screenshot, you understand now. You can see that Kí ni ẹ̀ mẹ́ta ni? Ẹ rí pé ìkan tó simple.
No, hold on. I have to take screenshots. They have killed my enemy.
Okay, so no, just look at the diagram and explain the diagram. You see it. Explain.
Yeah, explain it, Abby.
Yes, explain it.
Okay.
You understand what I'm saying?
Okay, so in this diagram, we have virtual network. We don't know there. We have virtual network 0, virtual network 1, virtual network 2. So we have 3 virtual networks in this. Okay.
Start from the outer region. That's how you start.
Okay. So in this diagram, actually, we have 2 regions. Region 1 and region 2.
Exactly. So you now pieces it. Kilo 1 region 1. You pieces it. Kilo 1 region 2.
Okay.
So
region 1.
Actually, because you already have the understanding.
So for region 1, we have 2 virtual networks. This is virtual network 1.
No,
sorry.
That's not the next thing. That's not the still. That's still not the next thing. If you see region 1, there's a big circle. That circle the whole region, right? So what is the next circle after that region?
Region 1.
That's resource group 1 now.
Oh, sorry. Yeah.
What if
So in region 1, we have
logo resource group money.
I think it is only one resource.
It's very simple now. So already,
I think it's the same resource group for everything.
Yeah. You can see that it's the same resource group, right?
Yeah. So we have
-4-5, that's resource group 1, 3. But if you, like I was telling you, take your time. First of all, start from the big picture down to the smaller one. The big picture is giving you region 1. So which means that whether you like it or not, when you are deploying whatever you are deploying here, it has to be in these 2 things. The one by itself has to be in the same region. Then region 2 has to be separate. So Telebaje East US. Nǹkan tó wà ní méjèèjì tó wá jẹ́ East US, ilé máa jẹ́ West US or Canada. You understand? So that's the logic behind the architecture you are looking at. So then after the region comes your resource group. So you first of all, you now create, the first thing you are creating here is your resource group. That resource group has to be in this region. So maybe when you are creating your resource group in East region, East US. So then after that, you now create a virtual network. So your virtual network, you must give it this IP name. A word of funny network address name of 10.50.0.0/22. You must give it only. So it's okay. So virtual network here, we need first dotted line. Then we'll be like first dotted line here. That's your virtual network. After you have created your virtual network, of course, you know that your virtual network will come with a default subnet, like I've always told you. So your default subnet comes with this IP address of 10.50/7.0/24. Okay. So inside your default network, you can deploy the first virtual machine C, which by default it will have 10.50.0.4. You understand? Then once you have done that, you go back to the VM2, the same VM. I mean, you go back to the next action, which is, of course, the whole region 1 okay. The next thing you want to create, you will now go and create your resource group. But lo and behold, it's still the same resource group, right? So you don't need to create another resource group. So the next thing to create is the next virtual network. We need 10.51.0.0 because the is 10.50.0.0, right? After you create your virtual network, you move into your subnet. So your subnet is 10.51.0.0/24. Okay. So after you create your subnet, of course, you don't need to create that subnet because that subnet is a default subnet, right? When you're creating your VNet, you can create your subnet. But then after creating a second machine, you now make sure it's in that subnet and you give it 51.0. So now the same thing goes with region 2, which is there's nothing new. So it's still the same resource group level deploy. But this time around, be careful to choose another region, right? So which might be maybe Canada, US, Canada, this thing, or Asia. Just pick another region, maybe UK South. So when you pick another region, you already deploy your virtual network, right? Then,
so I have one question.
okay,
So if we say so um USA is a region, right? But US East West and US East clinical they are the availability zone, right?
I didn't get that, sir.
USA on its own is a region, just like Canada is a region, right?
Yes, sir.
Okay. So the US East West, US East North, South, whatever, they are the availability zone.
Okay.
Àbí wọn kí ló available zone ní bíbá you have never even mentioned it before.
I'm trying to understand what you're saying. I'm still not getting what you're saying.
Okay, and that's what I'm saying. Okay, we are talking about region. So here we are using the local region and the global region. My question is USA is where to them be okay, let's say Texas and maybe Texas and New York now. They are local, right? You don't get me. Okay. I don't actually know what they have in USA. But let's say example, USA East and USA West now.
Yes.
They are not region. They are local region. I mean, they are local, right? They are not regional. I mean, they are.
No. They
What
are
I want to say
global.
is, so US. So what is US region and Canada region to each other? That is global.
That's global now.
Okay. So US East and US West, they are local and they are regional, right? Sorry, regional person.
No. They are still
I want,
global.
I want a
They are
clarification
still
on
global.
that.
They are still global.
Okay. But tó wá jẹ́ pé ìkan wà ní tó wá jẹ́ pé so okay, they don't have availability zone in Azure. They don't use it.
Don't worry about availability zone.
No, I know. I just want to. I know it's not part of what we are doing now for the pairing. I just want to be sure. Do they use availability zone at all here?
What did you say?
Do they use availability zone in Azure?
No, now this is just for you to
Okay.
deploy resources by telling yourself that yes, you understood this diagram, you understood this architecture
Okay.
on your silver.
Okay, man. Okay.
It has nothing to do with all those systems. Where is it? Can we
I'm
go to
just asking the question outside of this. I'm just asking the question outside of this. Move on, nothing so much in Bailey when we do region and global. Okay, so what do I do now?
I will send you the link. You start working on it. You understand?
Okay.
But I just want you to have an idea of which for so once you create this, then you pair these two together. Then this is called local payment. Then you do a global payment, right? So
Okay.
objective, see, these are something you are going to create an infrastructure environment. You deploy 3 virtual machine and all of that. You can view the laptop. Let me check. Okay. If you copy this script, run Google at the same time. So about tax
Okay. So
configure local and global network pairing, configure this, blah 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 blah. So don't worry, we'll do it. Let's do another check.
mm.
So your company is implementing an Azure virtual network. You can read so that you can answer it.
Your company is implemented an Azure virtual network pairing to enable connectivity between virtual network. You're working on the plan to support share access to gateway and resources and to control internet communication. A few team have submitted question and configuration requests for your input. The IT team needs information about how to check virtual networking pairing status and peer and verify peer connections. The market department has resources that need to be accessed by virtual networking in different regions. Answer the following question. Choose the best option for each following question. Select and then check your answers. The company is implementing an Azure peer solution to enable connectivity between virtual networks. So,
So question 1.
when virtual network application, what is the best status for both networks in the pairing? When virtual network application paired, what is the best status paired?
Mi ò fi hàn yín lẹ́ẹ̀kan yẹn. So yeah, I was talking about pairing. You have to check your parent status. So you can check the connectivity status of your parent in your virtual network pairing. The status depends on how your network deployed. Your pairing is successful to both virtual network. It depends. It's called connected. Check it depends. This is the answer to
Mm.
this. So because most people can skip a lecture. The deployment within the Azure, the deployment status condition are initiated and connected. For the classic, the implicit status condition is also when creating initial network first time, the parent status for the first version is initiated. Okay. When it creates the subsequent pairing from the second to the first version is the pairing status for both and what which one is called connected. Okay. Let's look at the question. So number 2, what approach enables paired virtual network to share the gateway and get access to resources?
What approach enables paired network to share gateway and get access to resources? Point to site connectivity.
Are you sure? How about gateway points?
What approach enables paired network to share? What approach enables paired network to share the gateway and get access to resources? Gateway transit, which is paired to point to site meaning something.
So which one are you going for?
Site to point meaning point to site meaning
Point to
point to
site.
site meaning.
Okay. So how is Azure virtual network pairing best described?
How is Azure virtual? That's big retrieval network is help in Microsoft Azure network. Virtual network stops where virtual network must be in the same region. Where virtual network it can be in different. How is Azure virtual network best described? Traffic between virtual network is kept on Microsoft Azure network. Virtual pairing to stop other resources. I'll pick E.
Is that?
Traffic between virtual network is kept on Microsoft Backbone network. Hey, mo gba gbogbo ẹ̀ àbí?
Gbàgbọ́. She gets it.
Wo mo ṣe? Yeah.
Now I was physically mentioning gateway transit for you.
I kept mentioning it too.
I kept mentioning it. And you like the cascope, and then we look cascope.
At least more pass.
Yeah, you did. 66%.
I got a congratulations message.
Okay, so I'm going to send you the link. So you start configuring it. So hopefully. Let's see diagram, yes.
Mm-hmm.
So let's do exercise 1. What's it possible exercise 1? What you do? Tax 1.
Chicken la fẹ́ lò ni. Ṣé lọ ẹ̀?
Can you say like can you partial?
Mi kò ṣe kí la máa lò.
Partial.
Wow.
Okay. So I want you to go and try your hands on this. Yeah. But we'll come out as my phone issue. Where to download the file here. Let's copy comment. Let me copy it.
Me. Ṣé kìí ṣe lè ta okay 5-4 láti lọ́jọ́ yẹn.
4 láti lọ́jọ́ yẹn.
Lápò for
Ṣé
the
ẹ download
download.
gbogbo file yẹn náà àbí? Ẹ download gbogbo file yẹn náà.
4.
Ṣé download gbogbo file yẹn?
No 4 ni mo download 4.
No, gbogbo ẹ download. Show me your screen. Because I've downloaded everything.
Okay.
I've downloaded everything because you might need to pick that file. Mo fẹ́ kẹ́ lọ bàjá fún ara yín. So $1, ẹ bá bàjá sí.
Okay.
It's very correct theory. So you creating those suggestions won't be a problem. Maximize your download. Only here now. I will last month. You see, I open it.
Chile.
It's the 104. I open it again. You'll see all lab, all files. I think that's when I pick out. So I'm going to sorry.
Màá lọ sí 05.
I'll see 05. Now méjèèjì lè máa upload. Méjèèjì lè máa upload. Ìgbà kan lè ti máa upload ẹ̀ o.
Ó ti yé bó ṣe lọ.
Ibi PowerShell yẹn lórí cloud lè ti máa upload ẹ̀. Cloud shell lè máa lò lè fi máa run. Lè ti máa upload. Ẹ̀rọ náà ti bá ẹ ṣe last time now.
Màá try.
Ẹ gbọ́dọ̀ ṣe rí ìfẹ́ lọ sùn báyìí. This is 1 o'clock.
A kò sí wàhálà.
Ìjọba bá pàdé. Ẹ gbìyànjú ẹ parí ẹ̀ because mo ti go through mo ti rí pé ibìkan ló lè fún yín problem yẹn. But thank God I already have the file downloaded with you. Gbogbo ẹ̀ náà PowerShell script náà you understand. But hopefully, but try your hands on it so that let me send this to you. With my bed, you know, 3 a.m.
You want me to stop sharing?
No need to stop sharing. I'm sending you the link. So LOC Teams can pick link. Just click on it. So you read one after the other.
Okay.
All right. So same time tomorrow. But let me show you party.
All right, sir. All right, kò sí wàhálà.
All right. Good night, sir.
Good night, sir. All right,